Hello. Hello. Right. It's not coming. And it joins. Harshavardhan, Rohit, Harshavardhan, can you hear me?
Sir.
Ask them to join. Ask them to join immediately. Hello.
Okay, sir. Okay, sir.
Okay. Put a message there. Right. Thank you. We'll wait for another 2 minutes. Let them join remaining students. Okay. Let's start with the. Yeah. I think most of the students were joined. About 20 students, and remaining they can join later. And by the way, okay. So in the last class, we discussed about the classification of surveying. What are the different types of surveying is there? Compass survey, total session survey, GPS survey, airborne survey. Harini, Harini,
Yes, sir.
please mute the the speaker.
Sorry,
Yeah,
sir.
thank you. It's okay. So last class we discussed the different types of classification of the survey part. Okay, so what are those classification? Compass survey, the tape survey, chain survey, and even for your what you call the total session survey, theodolite survey, dumpy level, auto level, and also with the what do you call the airborne survey, aerial survey, drone survey. There are different types of surveys. Okay, this is what we discussed in the last class. So how you are going to measurement? What are the units? What are the surveying measurement units and types of errors? Okay, what are the errors? What is error? And what are the different types of error that we are going to discuss in this class. And also we are going to discuss the topographic maps. What is topographic map? What is there in the topography map, which we have surveyed from the ground, and what is the map layout, and it's a survey of India map numbering systems. All those things today we are going to discuss there. Right. So let's start with let me share the screen so that you can see the PPT of that. Mohan, the voice is audible here. Mohan.
Yes, sir.
Okay, that's great. Okay, can you see the screen now? Just tell me. Yeah. So the measurement. See here in the measurements and the units, how you are going to take this. Okay, there are linear measurements, or horizontal or vertical only, and here there are some the angular measurements which are also involved here. Okay, there are two types of measurement. One is linear measurement, okay, and another one is angular measurement. Okay, linear measurement is only for the straight lines and the where there is a flat line. Where there is angular measurement, angle you need to measure it. Okay, so that is called a angular measurement. Angles with the linear, you need the angle as well as the distance. That's called a total measurement. So one is linear measurements are horizontal, and also it's a or it may be vertical. Okay, so here another measurement called angular measurement. Angles, they may be a 10 degree, 20 degree, 30 degrees. It's inclination of the topography. Okay, that is a one. Commonly we use the linear units in surveying. That's kilometer. How many kilometers from here to Yalanka, from here to Majestic? What is a kilometer? That's a common measurement. Generally used to do that, and you can do the put the measurement units like a meter also, as per your convenient, as per your the requirement. You can fix the the units. Say for example, if the area is very big, even if you put it the meter, you can easily convert back into the kilometers. So most of the things are generally we for surveying part we use the meter. Okay, and also for some extents, as I told you that depends on the requirement. Depends on the area. If the area is very small, you are going with the feet. Unit is a feet. If the area is little bit bigger, you will go with the meter. Okay, if the area is very vast areas, like kilometers together, you used to go for the kilometer. Maybe 100 kilometer by 100 kilometer, 30 by 30 kilometer, length 10 kilometer, and width by 25 kilometer. What we'll do? We are not going with the meter level. We'll go with the kilometer. That is the best way. Or you can convert it. That's not a problem. That is how there are different units are there. Okay, and even some extent we used to do the centimeter and millimeters, and even inches also. Okay, and later you can, if you want, you can convert those things. Okay, that is the thing. So here there are four types of even centimeters also here. Kilometer, you can take it as a surveying and units, and meter also you can take it the readings, and even millimeter, centimeter, and inches. Generally for construction of the houses, we used to take the feet, because 30 by 40 sides, or it may be a 30 by 60, or it may be 100 by 50 sides. That is, very small areas will go for the feet wise. That you can convert 30 by 30 site, you can convert 100 square feet, sorry, the 900 square feet, 30 by 30 sites. If it is a 30 by 40 sites, 1200 square feet. Okay, if the same area is like this, so for in a big vast areas, like say for example agriculture land, what you will do, you will go with a meter. But in government surveyor, what they will do, they will go with a chain surveying, tape surveying. Okay, that's also you can do it in a meter wise. Okay, that's how the things. So in the for measurement of angles, okay, measurement of angles, there are some Siemens system is used. One circumference is equal to 360 degrees. That we are not much using that. What is the scale now here? Scale is nothing but you are representing the ground information into the map with a scale, converted scale. Scale is nothing but representing the features, whatever you surveyed from the ground, that you are going to plot it on your paper, A3 size, A4 size, or it may be A0 size. Okay, right. Say for example, if you take the if you survey the BMSIT campus, our college campus areas, complete each and every boundary of our college campus, how we are going to put it into the A3 size map. This may be the half a kilometer, this may be 1 kilometer. Okay, and some sites it may be 1.2 kilometer. It depends how the shape is there. So you surveyed with a total station, or it may be dumpy level, auto level, or it may be plain table surveys, or it may be with your GPS surveys. How you are going to plot those things, plot those surveyed the data into your map. While putting the map, while do the interpretation or plotting those data into the A3 size or A0 big one. Okay, or it may be a A4 size. Which scale you need to require? Depends on the paper availability, depends on your data. You can change the scale. Okay, that is how it is not possible, and also it's not desirable to make maps to full scale. Full scale in the sense, say for example 1 kilometer of 1 kilometer area, you cannot show it in the map. You have to reduce the scale. So if there is a 1 kilometer by 1 kilometer, length is 1 kilometer and width is also 1 kilometer, what you will do? If you are if you have the A3 sheet paper and you need to plot within that the 1 kilometer by 1 kilometer areas, what you will do? What is the centimeter, the width of that? That may be the 50 centimeter of your A3 size. So what you will do? 50 or 60 centimeter, I think, yeah, 60 centimeter. A4 311. So 60 centimeter. Okay. So what we will do? So you need to 1 centimeter is equal to 100 meters, or maybe a 200 meters. Right. This is x-axis. Y-axis, what is the distance? As based on that, you can reduce the scale. 1 centimeter is equal to 100 meters. So 1000 meter is equal to 1 kilometer. Right. 1000 meter is equal to 1 kilometer. Right. So you need 10 centimeters. So if you are going to fix the the 1 kilometer by 1 kilometer boundary into A4 size paper, you need just 10 centimeter width and 10 centimeter length. So in the scale, you can write it as 1 centimeter is equal to, just do this. Okay, it's okay. So 1 centimeter is equal to 1 centimeter is equal to 100 meters. That's all. So you need a 10. Horizon x-axis 10 and y-axis is a 10. That's it. That's it. Okay. So if your map is 1 centimeter is equal to 10 meters, or that's called your 1:1000 meters, 1:1000. Okay, this is how you can convert the things. So it is not the possible, and it's not possible and also not desirable to make maps to full extent. That's a full extent. Whatever you are collecting the data from the survey data from the ground, that is a full extent. All distance are reduced by fixed proportions and drawings are made. That's what I told you, that you can reduce the proportions, reduce the scales. Yes, 1 centimeter is equal to 50 meters or 100 meters or maybe 500 meters. Depends on your area and depends on your paper. Okay, that's how the things. And scale of the map or drawings is fixed proportion which are every distance on the map bs to and corresponding distance on the ground. Yes, say if you want to show the small the features of the earth, say for example in BMSIT campus we have many trees are here. Okay, we have different departments. Admin block is there and BSN block is there, hostel blocks are there, and that side is the MCA department is there. Okay, that also you need to show it. This is how you need to fix the scale. You cannot fix the scale in 1 centimeter is equal to 500 meters. Okay, so you need as per your features of the in your surveyed areas. Okay, that small feature also should, you can interpret, you can plot it in the paper so that it can be visible. Okay, right. So this is how you need to fix the scale for drawing purpose. Okay, right. So here if the 1 mm on the paper, it represents 1 meter on the ground. That's how then the scale will be the 1 mm is equal to 1 meters. Okay, 1 mm is equal to 1 meters. This is how the things, or 1 centimeter is equal to 10 meters, or you can say 1 is to 1000. Okay, you can, the generally the most of the the surveying map reducing this case. That's because of the features which are on the ground. You need to show it in the map by plotting your data and the interpretation, and even small features also, it has to be visible when you plot it. Okay, that is how we need to change the scale, and you need to convert the scales. Okay, to make a scale of independent of units, it's preferable to use the representative factors, which is defined as the ratio of distance 1 unit on a paper to the 1 unit on the ground. That's why that relative distances must be, you need to take it. Okay, that's some things here. So next one is the plane scales. Plane scale is possible to read two dimensions directly, such as units and tens. Okay, and diagonal scale, say in the plane scale only units and tens could be shown, whereas in the diagonal scale it's possible to show the units and more than hundreds. Okay, units and tens are shown in the plain paper scale. Okay, and it's triangular triangles also you can use it if you required in the particular case. It's not anywhere. And next part is that fixing position of new control points. What do you mean by fixing of new control points? For fixing of new control points with an respect to the already fixed with the points, at least two independent process should be followed. Say for example, if E and B are two already located control points within your surveyed areas, and with respect to them, new control point C should be located. Okay, apart from the minimum two measurement required, one more is should be taken that you can measure it. Okay, that's the thing. And next one is the Survey of India and topographical maps. Okay, you understand what is the scale, what is the measurement, okay, and what are the the requirement, and you need to take care when you are doing the survey, and when you are going to map it, when you are going to plot on the paper. Either may be A4 size, or it may be A3 size, or it may be in your A0 size. Okay, that's how that is. So here in the Survey of India and topographical maps. So here the Survey of India is the oldest scientific department government of India. It was established in 1767, very old, and East India Company, which is ruled India at that time. Okay, and it works under the Department of Science and Technology, and also it is assigned to the role of principal mapping agency of the country. So the whole India is surveyed, and each and every corner of the places in India this survey of India. Survey of India, I would say it's right called SOI. Survey of India has, surveyed the complete, on the features of the surface of the earth. Either it may be a valley, or it may be hill, or it may be, mining old working mines, or it may be current working mines, or it may be a, villages, post office, city, okay, railway lines, roads. If there is a tunnel is going there, that also they have surveyed it. And even for the reservoir, dam constructed areas, dam locations, and power lines, high tension power lines, even in a small roads, you know walkable roads also they are mentioning there. If you take the national highway, state highway, okay, um, and even small, the roads, major roads, minor roads, and even walkable roads also they have surveyed. Okay, and also they have surveyed the forest land is there. If there is a forest land, if there is a valley, if there is what you call this, highly rocky exposed areas, open scrub land, okay, and if there is any agriculture land, if there is any what you call, oh, I would suggest that, uh, let me open the the survey of India to push it, so that you can easily okay, okay, can you see the topo sheet? It's visible. Hello. Yeah, it's a little bit blur. Let me open the new one,
Yes,
another
sir.
one. It's not visible clearly. Let me show you. Okay, GS satellite. Let me show you the. Okay, just a minute. So I want to show you the some of the very good the topo sheets, which we can easily identify the many features in the topo sheets, and those topo sheets are very very old, but it's detailed information you will get it from there, and that is a base map for all of you. That is a base maps. No other map will give in the such a informations. Okay. What's it? Data question maps. Yeah. Okay. I think it's visible. Yes. Yes. Okay. Still the text is little bit blur. The map there. Okay. Can you see this? Which one is visible? You tell me. This is visible.
Yes,
Okay,
sir.
this is a Gadag city, eh, which we have the survey for that. And here you can see this, what is called RF. RF means this is a reserved forest area. Okay, and here is the the benchmark. You can see this 665.4. This is a BM means benchmark. Okay, and here is the small town that's called Hulkoti, and here is a South Central Railway rail now. So yeah, they map it. I mean, the surveyed it, and and these are all the small streams. Small streams. Can you see this? This is a small hill where the first order streams. This is a first order streams. Small, we can call it as in small streams, which are originating from the elevated areas, or it may be from the mountains. Okay, from here it is coming. These are the small streams and joining together and becoming the big river here. You can see this like this. It's going on joining the major streams. This is a river streams. I mean the river systems. And there is a small roads also. You can see this, and there is a track of that. Okay, track follows bed. Okay, this is a small one, and here you can see the contours. That's the most important. Whatever you are doing the survey for that, you need the contours, you need the elevation data, you need the RLs to do the estimation of cutting and fillings of the particular areas. That's the one thing. If you are going to do the pipeline survey to water supply for the Bangalore city, or it may be small town, or it may be for the what you call this district places, you need to fix the pipeline. For that you need to do the survey, elevation survey, which area is highly elevated, which area is the which place it is a lowland, highland, and what is the difference between the RL, and how much you need to go for the deeper level to supply particular the place. Okay, how we are going to fix the pipeline, those things we need to survey. That's called your the survey. What are the features or the remaining features? This is another one. Okay, there are many places. Think about Tangri. Okay, that is the thing. And here, if it comes here, see here, reserved forest. RF means reserved forest. These are all green boundaries are there. That's called a reserved forest. Okay, and there are some the local places, open scrub land. Nothing is there. Just it's open scrub land. Okay, and these are all the streams. It's just like this. How the streams are flowing here from first order to first order joining together, second order. That means the water, the accumulation is more here, and then joining together and joining second together, third order, joining wherever it join and continuation. That is a fourth order, and then becomes a fifth, sixth order, and it can become the big rivers there. Okay, and I would say it's a see here. You can see this power line. This is a power line for you, and this is a telegraph or telephone lines along with the roadside. This is a road actually. Okay, and this is your base map for your any civil engineering work. If you are going to construct, if you are going to locate for dam construction areas at early stage of the site preparation, or it may be a site location, where is the best location for construction of a dam for a particular the river. Okay, so for that purpose you need this data, you need this topo sheet. No other map will give you the this much of the detailed information except this topo. Yeah, here you can see this that is a very this one. Here you can see this. Yes, these are the water bodies, small water bodies. Okay, they put the check dam here, and for the this is the streams. They put the small check dams. They state the water here, and here you can come here, and the Gayatri Kashyap small check small dam here. You can see this. What is this? Some river, Suvarnakashi river. Yeah, and here is the this Ranganadu. Okay, Ranganadu State Forest. Okay, and this also small, the what you call this water bodies, and they put small check dam for this stream to supply the water for their nearby the agriculture land, and also that will increase the groundwater level, because when the water is standing stay at one place on the surface of the earth, so that it will start percolating into the subsurface. It will start, percolating and joining the subsurface, groundwater. Okay, that is the one. These are all the, if it is not a blue color, that's called a dry. That time they surveyed it. That's how it's. Otherwise, it's a blue color. This is another one. So this is a major streams. See here, it's a big river. See here. Okay, and this is a, complete, this is a, one place only. I would say it's uh, where is this? Just let me. Okay. How you are going to read this map? Particularly, there is a, how to read the, the topography maps here. So top is the country name, and refer to this map as a 1:50,000. So whatever you can, whatever you are, looking this, the features are visible on the this map. This is 1:50,000 scale. That means 1 centimeter is equal to 500 meters on the ground. If you measure from here to here, if it is a 1 centimeter, that is equivalent to 500 meters in the ground. Okay, that's called a map scale. Okay, refer to this map as 1:50,000. Okay, write that. So most of the topo sheets, they are fixed as a 1:50,000 scale, and next one is the 1 is to I think 25,000 is also there, 250,000 also there. Okay, it depends on the requirement. They have, fixed that. Okay, this topo sheet number is 48 m by 11. Okay, it's a first edition, 48 m by 11. This is a series number. Okay, this is a whole country code of this. So this topo sheet is 48 m by 11. Okay, and it's see also here we discussed that variation of magnetic north, true north. See here, magnetic variation from the true north about 2° west, 2° west. Okay, that is surveyed. That is especially in the 1970 when they surveyed this, surveyed the features of the earth. That's a survey date, 1970. Magnetic variation from the true north. True north is that is there in the 0° or 90°. Sorry, the 0° or 360. From that, there will be a variation towards west or east. Okay, if this is a 360 or 0°, it may be towards east or it may be towards west. So here the map, especially this map, generally the north will be in the this direction. Hitesh Gowda, Manohar, Manoj.
Yes, sir.
The voice is audible.
Yes, sir.
Okay, okay. The screen is visible now. Screen is visible.
Yes, sir.
Okay, okay.
Yes, sir.
Right. So this is generally, it is the north position here. This is the north position always. East, west, north, south. If you take any map, north is always in the upper side. It's showing the, north direction. Okay. This is the north, east, west, and south. Okay. And this is the topo sheet number is 48 m by 11. Okay. And this has been surveyed in 1974 and 75. Okay, these are things. This is which place? It's a Dharwad district. Okay, this is a Dharwad district. And now we are going to read it. Mulgunda, yeah. So here is the index for this particular what you call this topo sheet. So road, metal roads, you can see that, and distance, the same distance for that. Unmetal roads, the dotted lines indicates the unmetal road, and metal road indicates the continuous lines. Okay, and there will be a track, footpath, and bridges. These are the symbols. It may not be visible properly there. Let me check with the other map. This is a little bit blurred. Zoom out means it can become the this one. I think this should be the better one. All right? Is it, Mohan? This is visible a little bit than that. Okay. And if there are any bridges and other things are here, ford and ferry and all those things with the symbols they are showing here. And the streams, I told you that streams, how they are, with the track of bed and unidentified canals, you can show with the blue lines. Water bodies are always showing the blue lines. Roads are always in the red lines. It's showing the red color. Okay. And dam, machinery of rock structures, all those things with the different symbols here or here. Okay. And river banks, and also with uh, 3 to 6 meter of shoveling steves, that also you can show it. Dry dry with the canals, oh yeah, dry and wet, that also they are showing here. Okay. Submerged rocks, okay, that's our exposed rocks, they are showing here like this. Wells can show like this. These are the symbols, how they are going to represent. With these symbols, you can easily identify this. Yes, this is a water body, small water body. Yes, this is a roads. Either it may be a state highway, or it may be in the major roads, or it may be in the small, footpath like this. You can see these small roads, very very small roads. Okay, and these are the streams, first order streams, second order streams, and also there is a elevation 660 feet, sorry, the meter. Okay, I will tell you that this is all the readings whatever you can see here, that is all elevation, especially in the elevation, those are all in meters, not in feet, not in inches. No, this is almost in the meter. Okay, this 700, 702, 701, 680. Okay, and 690 here. From here to here is the 10-meter distance. Sorry, the 10-meter elevation difference. Okay, this is in highest elevation. This is the lowest 10-meter distance. And when it comes to here, 683, 690, 683, 7 meters. Okay, 7-meter height here and 7-meter lowland here. And this is how the all the features. Okay, contours and all. Okay, now next feature is that railways, broad gauges, all those things are, you can see the dotted line with the black color. Okay, and here is that what is this? This is called a mineral line, and subway telegraph lines. Those things are looking here, and contours. Okay, and slopey, rocky slopes, cliffs, certain cliffs, and the hill and valleys. You can show it like this. Okay, sandy feature, if it is there, you can show this like this. And yeah, is this I told you that refer to this mesh 1:50,000. So in that case, 1 centimeter if you measure from here to here, or it may be 10 meters. So 1 meter from here to here, 1 centimeter, that is equivalent to your 500 meters in the ground. That you keep it in mind. That is the first things. Okay, and next part is that here, how you are going to read this. So you have seen the all the the index what is there in the topo sheets, the railway line, roads, different types of roads, railway line. Okay, high tension power lines, streams, rivers, dam. Okay, and also the water bodies, and also the bridges, and also the dam, reservoir, contours, benchmark, village boundaries, taluka boundaries, district boundaries, right? And also You have seen the rocky areas, open scrubland. Okay, almost all whatever you can see on the surface of the earth, everything is mapped by the Survey of India, and they plotted in a systematic way, and they are producing a lot of the topo sheets that we call it as in topographical maps, which are surveyed from the government of India. Okay, this is the base map for you for any civil engineering project. If you want to go for town planning, you need the topography first. Of course, nowadays you got the latest information of the town, or it may be village, or it may be any part of the world. We have the latest the information. I mean, the maps are available. That's called a satellite imageries. Okay, that is a expensive. The cost wise, and this is a very what you call it's a very less price. Okay, but it's a more information you will get it from this here. From one topo sheet you will solve almost all the problems. So preliminary investigation. So if you want to construct a dam here, how many villages are going to submerge in this particular catchment? Say for example, this is your location. Okay, what you need? Okay, your dam height is maybe a 50 feet height, or it may be 100 feet height. So how much the backwater is going to store here, how many villages are going to submerge in this patch, and how many agriculture land is going to submerge, and also major part is where you are going to give the settlement, I mean the relocated place, and the compensations, everything we have to calculate with this. This is a catchment, this is you are going to construct a dam here. Okay, and there are if there is any roads are passing across this, railway track is passing across this, everything you need to take care. You can study with the topo sheets. Okay, right. And yeah, so here this is a topo sheet that is called M40, 48 M by 11. Okay, surrounding this topo sheet there are many topo sheets are 1 2 3 4 5 6 7 8. 8 topo sheets are surrounding with this. Adjacent to that, it's a boundary, common boundary for 48 M by 11, 48 M by 15, 48 M by 8, M by 12, M by 16. So these are all sharing the boundaries. Okay, either it may be a state boundaries, or it may be in taluka boundaries, or it may be a district boundaries. It's a sharing, it's a continuation. Say for example, say this what is called Shirhati taluk. So Shirhati, it's a 4 kilometers there. Where it is coming, it's the end of the road here, but it's a continuous. You can see this Shirhati road in the next this one, that's called your M by 12, M by 12 topo sheets. Okay, this is how the things. When you go back to any other rivers and things and eastern parts, see this river is moving here, right, towards eastern part, towards east. See here, this is a very big river catchment. It's flowing towards east. And what is the topo sheet here? That you need to take this. That you need to check with this here. M by 15, 48 M by 15. If you take the 48 M by 15, and you can easily identify where it is going, this river, and is there any how many villages are there in that particular nearby areas. Everything you can easily identify from this topo sheets. Okay, and here this is a thing. Okay, this is how to read the the features, what are the features from the topo sheet, and with respect to the land, with respect to the ground, with respect to the surface of the earth. That's called the topography. Topo means surface of the earth. Okay, that whatever you have seen in the engineering geology class, in the topmost shell of the earth is, that's a crustal part. Okay, on the top of that, the crustal part, the surface you can see on the visibly, and you have seen this You have seen the valleys, you have seen the rivers, you have seen the hill, you have seen the agriculture land, you have seen the rocky areas, big rock exposure like a Nandi Hills. Surrounding the Bangalore, you can see the only the granitic bodies, igneous rocks. I would say it's igneous rock. Not only granite, it may be a cyanite, it may be a dolerite rock, it may be the cyanite, dolerite, gabbro, almost all the rocks, igneous rocks you can see surrounding in the Bangalore. Even Tumkur districts, Ramnagar, Mysore, and even in Bangalore North, Nandi Hills. Okay, almost all the areas you can see the granite. Either it may be a color, maybe the gray granite, or it may be pink granite, or it may be greenish white, or it may be a gray color granite. It's completely, you can see the igneous rocks here. That's why the here most of the earthquake is, even if it is happens, very effectiveness will be the very less here in the particular areas. Okay, so this is the things okay, about the topo sheets and heights and contours in meters. Look at this here. See, whatever they have surveyed here, heights and contours in meters. See here, what is this? Where is our 683? They are not written here in the meter or centimeter, or it may be in the feet. No. So understood that 683. This is RL, this particular place, and it's in meter. And the contours. See, it's a 700. Here you can see the 700. This contour is flowing here, and this is completely, this area is only the 700 meters. Especially where the contours are showing the lot of the variation, where there is a hill, where there is a valleys and hills are there you will get very the contours, these things. Let me show you this. This also going to become the blur, man. Yeah, here you can see this. See this. No. That is so bad. Yeah, here you can see this, the contours. See, this is a 800 meter. 800 something is there. Okay, this is a 829, and this may be the two cases here. One is, it should be this type of symbol in the contours. These are the contours. So if maybe showing the valley, or it may be showing the hill. So if it's showing the hill, means there should be the first order streams are flowing here. From the top of the mountain, it is started Zari or first order streams on surrounding that. That is the first thing. And you can see the surrounding areas 829. Okay, so this is lower than this, and also you can see this 897. Okay, and next one is the 800. Yeah, here is the 740, and here is the 897. Why they are showing the triangular mark? It's the highest elevation surrounding that place. This is a ridges. This is a mountain place. It's completely, it's a series of mountains. Okay, and this mountain, you can see this. You can see this 822, and this is something 800. Yeah, it's a 800, 820, 780 here. Okay, and here comes the Malasamudra. Okay, and here you can see this is completely your the ridges, hill is flowing like this, and rest of the areas are little bit flat. That means here 700, and here is a 747, and here is a 717. It's a 740. Okay, suddenly it's a 700. Sorry, 822, 822, 800. So that means this is coming like this hill, and again flat land here. Okay, this is all about the today's class, how to read the topo sheets, what are the features you can easily identify from the topo sheets, what is the uses of the topo sheet. Uses are, first As a civil engineer, you are going to use it for tunnel construction, dam construction, and also for the dam, road, railway, town planning, layout, and other than that, there is irrigation, canal construction, dam construction, and also for the what do you call this high tension power line establishing, and for even for we use mineral exploration and also for the mining. And next part is that it's agriculture, ecology and environment. Okay, this will give the complete history, complete detailed information of the particular place, road network, railway network. Say for example, if you take the Bangalore. So if you are going to say, if you are going to settle in the, if you want to settle in Bangalore or in Mysore, what are the nearest airport? What is the nearest railway station? What is the where is a dam areas, recreation center, or it may be what are the eminent place, the basic facilities or the nearby that place. From that you can easily identify. Other than this, if you want the latest one, this is surveyed in 1974. The lot of changes is happening in the topo, in the surface of the earth. So those things, if you want to learn it, you have to take the satellite imageries. Those are available in the website, as well as the if you want to purchase, you can purchase from the National Remote Sensing Center, Hyderabad. Okay, that is there. That is from the IIRS. So this is all about the today's class. So let me shorten this. All of you, started the MOOC, which I have floated in the link in the WhatsApp group. Hitesh Goda, Madan Kumar, Manish, Manoj,
Yes, sir.
Mohammed have started. Before 20th, you have to finish. That's a very simple one. I think, which I showed to you. That's a MOOC. I think it's a very, very easily you can finish that one, because if you're not done very early, that's details which I have for here. This is a link I shared you guys, and you need to finish this MOOC very within 20th. Okay, this is an introduction to
Sir, can
GSM.
you share that link in group?
Huh? Hello, tell me.
Once again, can you share that link, sir?
I will share it now only in the WhatsApp you want, or in the
WhatsApp, sir.
WhatsApp, na? Okay, I'm going to share it now only. Okay, or 2019, right? Okay, right. Got it. So you finish the less possible before 20th, because after that you are not going to, this, because this, BMS site is supported this one. After that, it may not going to open that. Okay, so that we need to finish it. Okay, that is the one part. And second thing is, yeah, okay, EVS is not for you guys. Okay, so this is all about the today's class. Next class we'll go for with the remaining topic, which is that is related to I think numbering. We need that, the reference maps, the contours, those things we can go with the next class. Okay, and let me take you the attendance there. Basic okay, so what's the date today? Which class? Right.